Hello and welcome to this tutorial where I will show you how to use OpenCloning templates to clone using the GoldenPiCS MoClo kit. To load the templates, click on Templates and you will see GoldenPiCS here. You will see that there are three options. The first one is to clone a single transcriptional unit into a BB3 plasmid. This is a plasmid that can be already integrated into the genome. The second one is to clone a transcriptional unit into a BB2 plasmid. These BB2 plasmids can be combined into a multi-transcriptional unit BB3 plasmid using the template below. So let's start with the first example. Let me load a finished cloning strategy in which you can see what we want to do. First, we are going to construct the final BB3 plasmid, and for that we will do a Golden Gate assembly with BPI1 enzyme, in which we will combine a promoter, a coding sequence, in this case the template or the example EGFP, a terminator, and then a BB3 special plasmid for going from BB1 to BB3. And then we will do an homologous recombination in which we transform this plasmid into phaffii into the AOX1 locus, producing an integration of the plasmid into the genome. So where do we start? So you come to templates, you go to GoldenPiCS, you click on single TU BB3 plasmid, and then you will be shown this template where you have to pick a promoter, a coding sequence, a terminator, and the BB3 plasmid. To reproduce the example from before, we're just going to pick one promoter from this list. Here we have a drop-down with all the available promoters from the kits, but we can also submit our own file by clicking here if you are using one that doesn't come with the kits. In this case, we're just going to pick this particular promoter. And then let's do the same thing for coding sequence. In this case, the kit only ships this EGFP one, and just pick another terminator. And here we're going to have to pick a plasmid. So in this case, we're going to take this one here, which integrates into the AOX1 locus, and it has the resistance cassette of kanamycin. So we pick these four, we click on submit to retrieve their sequences from AdGen. And when we have them all, we then do the Golden Gate. So here we have the 4 inputs to the Golden Gate, and we're going to say that we're going to do this with BPI1. This is the enzyme we're going to use, and we want only circular assemblies. And when we click on submit, we will get the product we desire, and then another product where we have all the backbones like I did together, which is not what we want. So we will keep this plasmid, and we can rename it to BB3 EGFP, and we can also say AOX1, for example, so we know it goes in that gene. And finally, now we have an homologous recombination step in which we want to combine this plasmid with something in the genome. What we can do already is to hide the ancestors here by clicking on the eye, so we have a bit less clutter. And here we're gonna go for locus in other assembly to load the genome region, and in this case I'm going to provide the assembly identifier of the phaffii strain that I'm using, and I'm going to look for the AOX1 gene, which is here, and I want some upstream and downstream bases with respect to this locus. And when I click on submit, I will get the sequence from the NCBI. Finally, I do the homologous recombination. I recommend increasing this homology to 200 since the arms are quite long. And then we'll get a single product that we can name, for example, allele or whatever. And this has the sequence of the final locus that we will generate in the strain. If you want to save this product to your computer, you can click on this arrow. Then you can save it as a GenBank file, FASTA file, which only contain the sequence, but you can also save it as a JSON file. The JSON file will contain the whole history. So for example, if I save it like this, and then I refresh the page, I can reload this allele here, and it will provide me with the full history of it. So now let's say that what we wanted to do instead was a multi-transcriptional unit insertion. So for that, instead of doing this, you would go to templates, you would select GoldenPiCS, and you would go to transcriptional unit cloning into BB2. And what this would open is a template like this one, in which, as you can see, we don't have the genome region. We just have the combination of 4 plasmids into a BB2 plasmid. So you pick like before, and you will have to do this for every transcriptional unit you want to use. In my case, I want an AB and a BC transcriptional unit. So to produce a BB3 plasmid with 2 transcriptional units in total. So I will do them individually. The first time I will pick a AB plasmid for the recipient, and the second time I will pick a BC and then save them when I finish. And finally, I will come back here and go to templates, GoldenPiCS, multiple BB2 into BB3. So that will load again a genome region, recipient BB3 plasmid, and then we need to add our BB2 plasmids here. We load the ones we would have saved. So this is the AB one, we add it here, and then the BC one, and there we have it. So we have this BC plasmid that we have created, this AB plasmid that we have created. We can hide the ancestors for clarity. So then what we want to say is this Golden Gate assembly should take the AB plasmid, the BC plasmid. So now we have them here as inputs for this assembly. And finally, we pick a BB3 that has AC, right? Because we want to combine an AB with a BC plasmid. So we need an AC BB3. We pick this one, we click on submit to get it from our gene, and then we can do the assembly, in this case with a BSA1 enzyme. Again, we want circular assemblies only. And when we click on submits, we will have the desired plasmid with the 2 transcriptional units combined. In this case, they are both EGFP. We choose this product. And finally, we will have to select again the locus in the genome. So again, we go locus in other assembly. We provide our assembly identifier, in this case, the AOX1 gene. And we get the genome sequence. And again, we increase this to 200. We can rename our BB3 plasmid to EGFP AOX1. And then we do the recombination and we'll get the final sequence.